Hello everybody. This is the second video for section 2.7. We just done talking about the right angles congruence theorem. We talked about the two theorems that relate if you got two angles that are supplementary or two angles that are complementary to the same angle, then those two angles are going to be congruent to each other. So this part of the notes has two other pairs. Okay, take a minute to copy these things down. All right, the linear pair postulate is, again, here's the theorem. This is just the example that goes with the picture. So, linear pair postulate basically says if two angles form a linear pair, then you know that they are supplementary. Now, again, we've talked about this before. We know it's just a property of a linear pair. They had to be 180 degrees. But this is the postulate. It's the formal language. How we're going to use this is basically, you're going to be told, in some proofs, you may be told, two angles form a linear pair. All right? So in the proof, you can just go ahead and say they are supplementary. All right? Without that proof, or without knowing that, you kind of had to make a few more steps in the formal proof, and so it just kind of cuts things down. You're given linear pairs, you know they're supplementary. So, the next angle, vertical angles congruence theorem, we've talked about it, basically just as a property. If you got vertical angles, then they're going to be congruent to each other. We've known that, but this is the formal language, the theorem. We're going to prove it. Again, the idea of a theorem is it's a statement that has been proven. Once it's proved, you don't need to prove it again. So, just as a reminder, vertical angles, they're the angles formed when two lines intersect. The angles formed by the opposite rays, so 1 and 3, those are vertical. 2 and 4, those two angles are vertical. All right, so to prove that vertical angles are congruent to each other, with proofs, like always, we start with the given information. Angle 1, angle 3, are vertical angles. That was our given information. That is the reason it is true. Okay, so for statement 2, looking at the picture on the right side here, we got a couple ways we could do this. It's really going to be the same. It's just going to depend on which angle you want to use. But I'm going to go with this route. If you look at angles 1 and 2, what do you know about it? Angle 1 and angle 2 are a linear pair. Okay, you put the angles, they're adjacent angles, you put them together, they form the line. The reason we know they're a linear pair, well, it's just the definition of a linear pair. That's what they are. Now, on the theorem we just looked at, we know, and actually, hang on, before I get to that next statement, we also know, if we look at angles 2 and 3, those form a linear pair. So we're going to make basically the same statement. Angle 2 and angle 3 are a linear pair. For the same reason, it's the definition. Okay, so now, knowing that they are linear pairs, the theorem that we just looked at in the last slide says if you have two angles that are a linear pair, you know they are supplementary. So, angle 1 plus angle 2 equals 180 degrees. And that was the linear pair postulate. If two angles are a linear pair, then they are supplementary. We can make the same statement that we did in statement 4 here with the stuff from statement 3. 2 and 3 are a linear pair, so angle 2 plus angle 3 equals 180, and it's the same reason, linear pair postulate. All right, almost done. So now, just like in the first video, we're kind of at like if you look at statements 4 and 5 here, we're basically at a system of equations. Both of these equations equal 180. So we can set them equal to each other. Angle 1 plus angle 2 equals. Take out this 180 degrees, take out this 180 degrees and replace it with angle 2 plus angle 3. Because angle 2 plus angle 3 also equaled 180. And that is, again, it could be transitive, it could be substitution. Those two things are very much intertwined. So transitive property of equality. Okay, now we're trying to prove angle 1 congruent to angle 3. And we basically have it. You look at our equation here in statement 6. If you subtract angle 2 from both sides, we have it. Angle 1 congruent to angle 3. The reason that is true is a subtraction property. And that's it. For the proof, at least. So we started with saying, yeah, 1 and 3 are vertical angles just because of the way they are orientated with each other in the picture. And here's the proof, okay? Again, once we've proven it, we don't need to go through these 7 steps again. It's done. You have vertical angles, you just say they are congruent to each other. All right. So some examples of problems that you're going to see, and we have seen these before because we've talked about vertical angles before. So I think we're just going to set them up. At least I'm going to set up the first one here on the left. We'll save the other one for in class. All right, so looking at this picture here. Again, we have two sets of variables. We've got x's and y's, all representing some different angles. It's always easier to use the same variable in an equation so that you can solve for it. So I'm looking at those two angles, 4y and the 17y minus 9. That's a linear pair. Linear pair postulate says they're supplementary. So 4y plus 17y minus 9 equals 180. All right, that's the way I would solve that one. So we're going to solve for y, just normal algebra for that. Then to solve for x, we got some options, but I think this is the easiest way. Looking at the blue set of angles, the ones with the x's in them, same thing. They're a linear pair. Because they're a linear pair, that means they're supplementary. So add them up. To equal 180. And then you would just solve for x. Okay. Something similar, sort of, in the drawing on the right, but like I said, we'll do that in class. That's it. Have a good night. See you tomorrow.